Alright, so here we go with introduction to derivatives. So when you have just some notation terminology, when you have, let's see, f of x or y, so the way you say that is f of x, or basically y, you know, that's your function usually. So when you see this notation right here, this is called f prime of x. This up here is your actual function, like your original function, right? This one is called y prime. And this guy is, you just say the letters dy, dx, okay? And this is your derivative. Now, if you watched the video, you saw a little bit about what the derivative means and all these different ways that you can do it. So it's the change in y over the change in x. So basically, it's the slope of a function at a particular moment. It's the slope of a curve at any particular moment, any particular x value. And blank of an object at any particular moment traveling on a path. It is the velocity of an object at any particular moment traveling along a path designated by the curve f of x. Okay. So then the last thing, it's the slope of a tangent line to a function at a point. So let's say we pick a point like this guy right there. So if I draw the slope of the tangent line, that's considered to be the derivative at that moment. It's the velocity of an object at that second. It is the slope of the curve, the slope of the tangent line. It is the derivative. So the slope of this tangent line is the derivative. Now, there are definite ways to find the derivative given an equation, but for today we're just going to treat it as like a more of like an introductory level. We're not going to like see how to do the derivative until the end using limits, but it does get easier, like a more defined way of doing it. So let's look at some of these down here. So if I had this line right here, so when you have a linear function, it's very easy to tell the derivative. If this is my f of x, my derivative is my slope. So look at the slope of this line. From here to here, what's that? 2/3. So I know right away f prime of x is 2/3. It's literally the slope the whole time. No matter what point I'm on, the slope is always 2/3. Okay? So this function, I can tell you that the equation is 2/3 x plus 1. So it has something to do with this right here, but anyway, lines are easy. All right, this guy right here, it's the line y equals 2. What's the slope of that line? So what's y prime? Y prime is 0. It's a flat line. Okay. All right, down here. So when you have a parabola, the slope is always changing. So what we're going to do is try to kind of like line up a line at these points. So like let's do this one over here. If I drew a tangent line, I would probably draw it like that, like this. So I'm going to just try to like estimate. So I'm going to say it starts here. And what's another good point? Maybe it comes through right there. So 1, 2, 3, 4, 1, 2. So down 4 over 2. Looks like the derivative at this place is -2. So y prime at this point is -2. But just at that point, just at -3. Okay. At 1, if I drew a tangent line, it would be a flat line. So f prime of 1, the derivative at 1, is equal to 0. And here, if I drew a tangent line, it kind of looks like that. Looks like my slope is up 1 over 1, up 2 over 2. So it looks like my derivative right here, my dy dx, my derivative at 3 looks like it's equal to 1. So remember, the derivative is the slope, okay? And earlier in Algebra 2, you would say that this was decreasing, then it changed to increasing. So remember when in Algebra 2, you would, or even this year, you'd be like, oh, it's decreasing from -infinity all the way up to 1. And we put parentheses here, we wouldn't put a bracket, so you didn't really know it or think about it, but it wasn't decreasing at 1. It was actually, the slope was 0. It was not decreasing because the slope is negative and then it turns positive. So it goes from a negative slope to 0, then a positive slope. Remember, the increasing area would have been from, interval would have been from 1 to infinity. So decreasing, increasing. That has something to do with a little bit later on too. Okay, so over here we have a cubic function. So if this is my cubic function, I just want to just go over one little thing here, and that's like what the slope would kind of be. I'm not going to figure it out like we did over here, but we know we'd have a positive slope, so increasing. Here my slope would be 0. I would have a negative slope, it's decreasing, a negative slope. Here my slope would be 0, and this part up here is increasing, positive. So while the x-intercepts are important, it's the maximum and minimum points that do stuff for you about your derivative. It's up, increasing, then it's negative, then it's positive. Okay? So let's see, next one. So if you had a function, negative 3x plus 5, what's the derivative? Well, the derivative is the slope. And because this is a line, I can literally tell you that the derivative of that function is always negative 3, because the slope of the function is sitting right there. It's always negative 3. Okay. All right, here we got a parabola though. I'm going to sketch a picture of the derivative. So the important thing to notice here is that it is decreasing. It turns to 0 right here. The derivative is 0, and then it's increasing. So right at this point, when x equals 3, my derivative over here should be 0. And all that I know is that it's kind of increasing and it's decreasing. So my derivative should be positive and negative. So also one thing that happens with derivatives, they go in order pretty much. So with, especially with polynomials, it's easy to tell. If you have a quadratic, the thing above that is a linear. And the thing above that is a constant. And then there's cubic and quartic. So it goes like this. If you know that your original function is a quadratic, the derivative is going to be 1 less than that. It's going to be up here linear. If you know your function is a cubic, then the derivative is going to be a quadratic. If you know your derivative is a linear, then that means that your function is going to be 1 above that, a quadratic. So it goes like this. You know, your derivatives, if your original function, you go backwards to tell the derivative. All right? And you go, if you're given the derivative and you want to find the function, you go forwards. And it tells you, you know what kind it is. So you'll learn that more a little bit later. But anyway, this is a parabola. So my derivative of a parabola is going to be a line. So it's actually a line. This is the important point that I know. I know it's increasing and decreasing, and so that means it's positive and negative. And that's all we know. We don't really know a whole lot about it. I just know that it would look like that, or similar to. Unless we found the slopes at every point, we don't really know the slope of this thing. All right, given that my derivative is 2, what's a possible original function? So you're telling me that the slope of my function is always 2. Well, that kind of sounds like this up here. It sounds like I had a line. So when I'm writing my original function, it's going to be a line. And remember, I do y equals mx plus b. So I know that this is 2. I don't really know anything else about it. So it could be a line with a slope of 2, and it could pass through 1. So it could go like that. Or it could pass, you know, go up 2 over 1, up 2 over 1. Or it could pass through 5. But it still has to have a slope of 2. Or it could pass through negative 3, but it still has to have a slope of 2. So basically what I know, a possible value for my function is 2x, and the number back here, I can pick anything I want, or I could just write this. So I don't know, why don't we put 2x plus 5? And that could be a possible original function, because it always has a slope of 2. All right. So this time here, make sure we're going a little backwards here. So this is the derivative. So the derivative it's positive. So you have to learn how to read derivative pictures a little bit different. When you're above the x-axis, that means that your derivative is positive. That means that you had a function that was increasing. Right? And then when your graph is below the x-axis, that means that your derivative is negative. And so that meant that you were decreasing. Okay? And the turning point was right here. That's where your derivative was 0. So this must have been, remember this is a line, so let me go back here, it's a line, so my original function must have been a quadratic. So that means I have some kind of parabola, and it's turning around at x equals -2. So it was increasing, then it was turning around and going decreasing. So I'm going to draw it, I'm going to say it's turning around right here. And it was increasing to there, because remember, before that was positive, so it's increasing, and then it was decreasing after that. Now, frankly, I could have drawn this. I could have also drawn the parabola like down here. I could have gone like this. I don't know where it is, but I do know that at -2, at -2, it was increasing. The slope was 0 here. Remember, the tangent line was 0, and then it was decreasing, okay? Because it was positive and then negative, above, below. Okay, let's look at this table here. So, derivative graphs get kind of confusing at first, but you get the hang of it. All right, so given this table is the values for the derivative. So every single x value, the derivative is -4. So since that derivative was constantly -4, I feel like if my slope, the only time my slope is always one number is when I have a line. So the original function must have been a line, and the slope of that line was -4. So my f of x must have had like a -4x and then plus or minus whatever. Like, it doesn't matter what was behind there. It just, this part is what matters. So what's the equation of the derivative? Okay, well, let's look here. My derivative is literally equal to -4 all the time. So equals -4. What could be an equation for f of x? My function could be -4x, why don't we say -10? I mean, it doesn't really matter what that one is back there. Okay. All right. All right, so let's go ahead and look at this one. Given this table of values for the derivative here. So what's the equation of f of x? So let's go ahead and draw this out. So -2 is -8. So -2 is -8. -1 is -6. 0 is -4. That's looking like a line right there. 1 is -2. Yep. 2 is 0. All right. 3 is 2. 4 is 4. Okay, that's a nice, beautiful line. It crosses at -4 and it goes up 2/1. All right, so I think I have an equation for that. Cross -4, so 2x minus 4. Okay, so that's a line, and it's the derivative. So since then my original function must be a quadratic. It was the thing above that. To get the derivative knocks you down a level. All right, so the turning point is right here at 2. The derivative was negative. This part is decreasing. This part is increasing. So before 2, my function is going down. After 2, my function is going up. So 2 is the breaking point. I can put that breaking point anywhere. I don't really, knowing this information doesn't tell me where that is. So I don't know, why don't we put it like right here? So before 2, I was decreasing. I was below the x-axis. See all these negative numbers right here? I was decreasing. So I was coming down, and then at 2, my derivative was 0, and then I turned around. Also notice this. -8 is a super steep slope. So you're super steep over here, and then you're not so steep as you come to 0. So notice how it kind of like my steepness slows down, comes to 0, and then I start rising back to steeper again over here. Okay, So what could be equation for f of x? Let's just make a parabola right there. F of x equals, I don't know, I moved it over 1 up 2. So x minus 1 squared up 2, and work that out. That'd be x squared. X times negative 1 times 2 is negative 2x plus 1 plus 2. So an equation, x squared minus 2x plus 3. That could be my original equation. Okay. All right, so let's see. Now, getting to the part where we're actually going to calculate something using our limits. You saw in the video that, that we watched in class, you have this business with the secant line, right? So if you want to know the slope at a certain point, what you do is you are going to pick that point, and you have a point past it. So it's like you're doing the slope between these two places. And then what you're doing is you're letting this distance get smaller and smaller and smaller. So that distance right there is h. So this point right here, that would be your, I want to know it's 6, right? My x is 6 right there. And then that distance is h. So this right here would be, that would be my x, and this place over here would be x plus h. And then this piece right here, the 6, that would be f of x, and this would be f of x plus h, the value at the x plus h part. So if I was doing my slope of this line, I would get y2 minus y1, so f of x plus h minus f of x, over the x's. I would do x plus h minus x. And so look at what that reduces down to is this. Okay. We are trying to do the limit as h goes to 0. So I want this point to get closer and closer and closer and closer to this point. H is dwindling down. And so eventually I'm just going to have a slope of the line that goes right up against the point that I want. Okay. It's not going to be a secant line, it's going to be a tangent line. All right, so anyway, the video explained that too. So let's get to what we have to do here. So if we're going to be using the limit definition of a derivative, we have to calculate some things. So remember, my ultimate goal is to get to here. So let's do some things along the way. I want f of x plus h. So f of x plus h is basically just me putting x plus h where the x is. So 3 x plus h minus 1. So that would be 3x plus 3h minus 1. Okay? So let's do f of x plus h, that same expression I just found, minus f of x. So minus all of this. Well, minus 3x, but it'd be minus a minus 1, so it'd be plus 1, and then all over h. So look what happens. These x's go away, these 1's go away. So I end up getting 3h over h, okay, which cancels out, and 3. So when I do the limit as h goes to 0 of this function right here has reduced down to 3. And remember, the limit of a constant, there's nothing to plug in. I can't plug 0 in here. The limit of a constant is that constant. So there is my answer. That gives me the slope. Look at that. It gives me the derivative. The derivative all along I knew was 3, and it gives me that. Okay, parabola here. So parabola, remember, so 4 minus x squared, that starts at 4, and it's like going down. So the parabola slope is always changing. It's increasing, then it's decreasing. All right, so this one's going to be a little bit different. All right, f of x plus h. So that means 4 minus x plus h squared. So I have to work this out. So we have some algebra here. So 4 minus x squared, x times h times 2, so plus 2xh plus h squared. So I'm going to work that out. 4 minus x squared minus 2xh minus h squared. Okay. All right, so that thing minus f of x over h. So this expression, so 4 minus x squared minus 2xh minus h squared minus f of x, so minus 4, but minus a minus x squared, so plus x squared, all over h. And let's see, 4's are gone, x squareds are gone. So I got 2xh minus x squared. So minus 2xh minus h squared all over h. Well, do you notice they all have h's? So let's cancel them out. that goes away. This reduces down to 1, and that's gone. So negative 2x minus h. All right, so I want the limit as h goes to 0 of that. So negative 2x minus h. All right, so hey, guess what? Plug 0 in there, and there's my answer, negative 2x. So when I have a quadratic, my derivative is right here. So basically, any time, so let's try 0. This point right here, 0, 4. If I plug 0 in at 0, my derivative should be 0, because remember, that's my turning point. That's my slope of 0. My tangent line slope is 0. So if I plug 0 into here, oh, look, 2 times 0 is 0. If I plug a negative number in, so let's try like negative 1. So negative 1 would be like right about here. The slope would be a positive number. So if I put negative 1 in here, I get positive 2. So my slope is positive. Let's put a number in like 2, right here at 2. Here's my slope, looks like that. So if I put 2 in, I get negative 4. Look at that steep slope, negative slope. Okay, so it's telling you your slope, but you have to tell it what x value that you want it at. Okay, all right, so these last two, we're going to use the limit definition of the derivative, like full on, not in these little pieces, to find f of the derivative. Now look, I know the derivative is going to be 4. So we're doing the limit as h goes to 0. So this guy right here. Make one big fraction. I need f of x plus h. So I need to plug x plus h into this. So 4x plus h plus 2 minus f of x. So minus this exact thing. So be careful. You can put parentheses around it, or you can just think it through. So minus 4x and minus a 2, because it's a plus there, all over h. So clean this up. Limit as h goes to 0. All right, so this is going to get me 4x plus 4h plus 2 minus 4x minus 2. So look, those 2's go away, the x's go away. So I got 4h over h. H's cancel. So the limit, I don't have anything to plug in anymore. I basically have the limit as h goes to 0 of 4. So it's just 4. There we go. So a line, you always know the derivative like right away. All right, this guy right here. So it's going to be a little bit more tedious. I think I'm going to find, never mind. All right, so my limit as h goes to 0, I need f of x plus h. So 3x plus h squared plus 5 minus this thing right here. So minus 3x squared, and I'll turn it into a minus 5 over h. So this is the bad part right there. Let's figure this out. 3, I'm going to have x squared, x times h times 2, so plus 2xh plus h squared. All right, so it's going to turn to 3x squared plus 6xh plus 3h squared. Then I have minus 3x squared minus 5. All right, so let's take a look. 3x squareds go away. And let's see. Oh, I forgot this plus 5 was after that part. So there was an extra plus 5 in there, and there I have a minus 5. That's gone. Yeah, that's what's wrong. All right, so let's look what we have left. H goes to 0. So got h on the bottom. I got 6xh, then plus 3h squared. Okay. All right, so this goes away, that goes away, and one of these go away. So I have my limit as h goes to 0 of 6x plus looks like 3h. Okay, so h goes to 0, plug that in. That means that's gone, and I just have 6x. So you'd have to tell someone the x value, and then you'd plug it in here, and that would be the derivative. That would be the slope at that moment. So we have a parabola, 3x squared plus 5, kind of looks like this. Okay, so if you told me an x value, and I plugged it in here, I could tell you the slope, like if I tried like 1. So there it is. Should be a nice positive slope. So if I put a 1 in there, the answer is 6, so pretty steep. All right, if I put 0 in there, the slope should be flat. Well, 6 times 0 is 0. Okay, that's it. Sorry the video is kind of long, but we probably went a little faster in class, but that's it. Bye-bye.